Solving systems by substitution. This is page 6, number 21. The first question to ask myself is, do I already have x or y solved for? Does one of these equations already have x equals something or y equals something? As I look at them, I'll call the first one equation 1, I'll call this equation 2, and neither one of those equations is already solved for x or y. And so the second question I need to ask myself is, what variable has a coefficient of 1? Because whatever variable has a coefficient of 1, that would sort of be easier to solve for that variable. And as I can see here, x in equation 1 has a coefficient of 1, and x in equation number 2 has a coefficient of 1. So I can pick either one and solve for it. I'm going to pick the second one. Doesn't matter which one you pick, but I'm going to pick the second equation, equation 2, and it is x minus 2y equal 1. And since x has a coefficient of 1, let's solve this equation for that variable. So I'll move the 2y to the other side by adding 2y, so those two y's cancel, and so x equals 1 plus 2y, 1 plus 2y, okay? So now I have x equals something. In this case, it's 1 plus 2y. I'm going to use this expression, 1 plus 2y, and I'm going to sub that expression into the other equation and solve for that variable, okay? This was equation 2, so let me take this expression and plug it into equation number 1, all right? So equation number 1 was x plus 4y equals 19. And I know x is this. X is the same as 1 plus 2y. And so what I can do is plug this or sub that in for x. Okay, when I sub in, I always put this in parentheses. So x, which is 1 plus 2y, right? That is x right there. That's what x is. 1 plus 2y, and then I have plus 4y equals 19, okay? So now, as you can see, I have an equation with only one variable, and that variable, of course, is y. So let's solve for y. Let's figure out what y is. I see parentheses, and so I need to eliminate the parentheses by the distributive property. Of course, there would be an invisible 1 right there, and so once I distribute the 1, I would still have 1 plus 2y. Still have 4y equal to 19. Step 2 is to combine like terms. I have 2y and 4y, which combine to make 6y. I still have plus 1 equals 19. I have variable on the left side, so get the numbers on the other by subtracting 1 from both sides so that those ones will cancel. And so 6y is equal to 18, and if 6y is 18, I divide both sides by 6. I divide both sides by 6 so that y is equal to 3. Okay, y is equal to 3. And so I'm halfway there. I need an x-y ordered pair to be my solution. I have what y is, okay? Now that I have what y is, I need to get the other variable and write my answer as an ordered pair. And so if I know what y is, I need to find some expression that says x equals something so that I can solve for x. And lo and behold, I do have an expression that says x equals something, right? X equals 1 plus 2y. And we know what y is now, right? We know that y is 3. So I'm going to take this, I'm going to bring it up here and plug it in, boom, right there. I'm going to plug it in for y, okay? So I have x equals 1 plus 2y, 1 plus 2y, which is 1 plus 2 times y. So 1 plus 2 times y. What is y? Y is 3, right? So x equals 1, and what's 2 times 3? Well, that's 6. And so x is equal to 1 plus 6, which is 7, right? So now I have x equals 7 and y equals 3. And so if I write my solution as an x, y ordered pair, of course I put x first, and x is this, so that's 7, then put a comma. And then what's y? Well, we know y is 3, so 7 comma 3. This right here is my solution to the system. This is the only xy ordered pair that satisfies both equations. If we were to graph these equations, we know that the lines of these graphs would cross at exactly that point, and only that point, 7, 3.